Welcome to my presentation about regression testing with prioritization. And how is this done? I've been using two peer-reviewed articles. First one is the regression test selection, RTS, and the second one is the test tube article. What is regression testing? In the RTS article, the authors describes that if code has been changed, then they want to ensure that untouched code does not change. To ensure that developers do some retests on unchanged code to see if this happened or not. Which method is used to prioritize? RTS is a technique which contains many methods, and this is the methods. RTS all technique, random ad hoc technique, minimization technique. These three I described right now, I talked about, is what the authors have been researched on before. So we're going to use these methods. And they have also implemented three new methods to be used: LRO, self-random, and the random man technique. In TT article there is just one method used as technique, and that is the TT technique. On what software is the methods tested? RTS is tested on evolving software system Model 1 and fault removal process Model 2. In this presentation I only talk about the results on evolving software system. TT is tested on programming library SAFE, Fast Input Output, SFIO, and also on tool named Inkle. About RTS techniques. There is several RTS techniques used to improve the costs and to prioritize a subset of test suits. First one is retest all technique, which reruns all the tests in the test suite and is used to when prioritize effectiveness rather than cost. A random ad hoc technique is a technique based on randomly picking percentage of the test cases based on the test suite. Minimization technique is based on picking minimal test cases from the test suite and that covers the changed code. One way to do that is to randomly pick test cases from the test suite until every new statement and modified code is being executed with minimum one test case. However, the authors in this article have implemented a constraint-aware prioritization method building on executing history and comparing them towards two controls. LRO N it builds on executing history with alpha as close as 0 as it goes. The time constraints allow us just to run a percentage of n of the original test suite. LRO N chooses the n percentage in the test suite with the largest likelihood. Makes it cycling through all the test cases multiple times. Another control is safe random n. It is using a safe RTS technique. If a percentage n is less than the number of the test cases selected by the RTS technique of the set, then the author picks a suitable number of test cases randomly. The remaining is being time-stamped and saved. If n percentage is larger than the number of test cases selected by the RTS, then the authors use all and adds the test cases randomly that have been saved before. Last technique is random n, which just uses n percentage of the original test suite. This one is almost the same as the random ad hoc technique. Test tube divides software into code entities which makes it easy to compute from the original code and to monitor. When executing test cases, they monitor the relationship between the test case and the system on the test to analyze which entities is being covered by the test. When systems have been changed, then check which entities that have been changed, then rerun last set of tests to see if someone has been changed. If neither have been changed, then no need to rerun unit test. If unit test has been run, previous covered entities need to be computed again. A notation is that what is changed in the system is programming language conditional. Result of the test. In the RTS test, evolving software system is first to test the fault age. Fault age means that a counter is incremental when a fault not being discovered. The test is going on until all faults has been discovered and erased, or until 50 test sessions have been executed. Comparing fault age on LRU N against random N. Random has lower median than LRU N, but in standard deviation, LRU has a lower value than a random. Standard deviation is based on how many faults is found on the 50 test sessions cutoff. Lower score means more faults found. LRU found all faults before 50 test sessions have been run. Comparing random man against safe random man. Safe random had lower median, average, and standard deviation. A note is that both did 50 test sessions and had outliers, meaning that some errors were undiscovered. LRU N versus safe random N. Safe random has lower median and average, but LRU has lower standard deviation, and the differences is increasing as N is increasing. Minimization has the top values in median, average, and standard deviation. The retest all and the safe techniques discovered almost every fault in every session. All other techniques sometimes miss faults, which did leading into more tests, which increased the average fault age. The authors did also test on total testing effort by only going to give top and low score techniques. Top total effort was retest all with both 100 average and median. Lowest score had minimization technique with a total of effort of median 5.1 and 5.7 on average. In TT, when they tested on programming library safe fast input SFIO, they presented the result for 18 of 67 functions in that library. The test was based on how many functions that has been retested and how many times after a single function has been changed, based on 39 test units. The function with most retests was sfnew, 45 out of 39 tests. Sfnew is a basic function which is often used in the library to create and initialize streams. The function with the least retest was sfs, scanf, delpol, sfpol, and sfpeak with only one retest. Tests were also done on a tool with name Incol, which aims to find out how much reduction they can get with regression testing based on two different versions. Version 2 that is going to be tested was created from version 1 and modifying a few output formats. The test suite had 8 tests, and each test is a Unix shell script. Each shell script is run then compared to saved result of expected output. When doing this A-test, it resulted in only 4 reruns, which gets a reduction of 50%. The authors did also test on SFIO with non-determinism. Non-determinism means that in specified points that a program can have various alternatives in program flow, resulting in function sfnew grew from 45 tests to 39 tests out of 39 with 6 other functions. The delpol function grew from 1 test to 2 retests, but function sff, scanf, sfpol, and sfpeak was unchanged. Both tests RTS and TT were done in programming language C. What is the threats and the validity of the threats on the result? Threats to the validity on the result in the article is that the authors think that instrumentation effects can impact their results. This effect can be occur when distinction experimental instruments. An issue is that all changes in a subjective program is being considered as false. In reality, some changes will be not considered as false, and this was on the RTS article. I could not find anything that was valid in the result in the TT article. What can be said of the research question from the result? According to the goal of prioritized regression testing, the authors have come up with the result that fulfills that goal, but also depends on which technique that's going to be chosen. If total effort is prioritized, then minimized techniques will be to prefer. If fault is prioritization, then retest all will be to prefer, and this is it in the RTS. TT technique also fulfills the goal to prioritize according to test on tool Inkle, where the reduction on total effort when retesting was reduced by 50%. Total effort in retesting function was also decreased, testing SFIO when some functions just were retested once out of 39, and highest retested was decreased by 4, making it retest 45 out of 39 has been made. Further plans for the authors in the RTS is to improve the cost models to clarify on their factors as overhead for a single testing session analysis for source code cost. The authors also want to expand their project with programs with more wide variation, natural obliging faults, implement and analyze other history prioritization techniques. TT authors wants to in future to implement the cost model created by Leong and White, also to incorporate TT with other test tools. In RTS article, to find faults, the safe technique is the best method to use. For example, safe random, and it had a score of 1.2 in average and a 1 in average in Model 2 test, which says that even if the technique is relative safe, it's not 100% finding the fault, so some of the faults is being undiscovered. So if the goal is to have 100% fault-free software, then I think these prioritization methods can't give you enough confidence to be used in that matter. RTS techniques is tested on 8 C language programs, and I think it's strange that the authors don't have C language programs to ask the validity of the results. I think that the authors should expand their technology in more programming languages, as example PHP and or Java. Then it will be more useful, flexible, and platform independent. I think in general it was a good article showing a lot of good and bad results according to which technique that was chosen, and that the information will be useful for future studies about regression testing techniques. TT do their test on software level written in C, which seems to be a good thing as long as the software is written in language C. As I have implemented when the authors have said software level means that the authors are testing on libraries and tools, which could have been better described in the article. I think the validity that I found in the article is that when all tests is tested on C, then I assume that the results is just valid for C softwares. The authors could improve the TT technique is trying to expand it to more languages, as example Java and or PHP, or some other programming language to make it more flexible, used, and platform independent. TT authors reduce the amount of function being retested, but never mention if there was any fault being discovered during this retest, and I guess that probably aren't, and that's great. But how can the authors be 100% sure that they don't have any faults? I think that the authors could have shown a function coverage report together with the result, giving more confidence that it actually works. Though 100% coverage can't confirm that we are bug-free, because it will take too much performance to test every single input and analyze the output. I think it was a very deep and good article in general with really good resulting, especially in finding faults. I find this article useful for future studies in regression testing techniques.